Yes, hi. Welcome to Hadoop class. This is Krishna Babu here, Big Data Architect. Today we will discuss like a Hadoop demo section. In this demo section, we will discussing like what is Hadoop, why Hadoop came to the picture, and what is the advantages of the Hadoop and the advantages of and the importance of the data. Okay, this is the topics we covered today. First is what is Hadoop? Hadoop is a open source product developed by Apache to handling big data. Especially to handle the big data purpose, Hadoop came to the picture. Okay, it is one of the open source product. Okay, again, before going to discussing this point, we'll discussing like basic points. Yes, the data point of time. We know very well all organizations have different types of data, generating these three types of data, namely structured data, semi-structured data, and unstructured data. All organizations generating these three types of data. We know very well the examples of the structured, unstructured, and semi-structured data also. Those data, it forms certain rows and columns. Generally, we say those data is a structured data. And unstructured data means those data is not possible to identify. It's not easy to understand. Those type of data generally we call unstructured data. And coming to the semi-structured data, those data is not purely structured data, it's not purely unstructured data. Generally, this type of data generally we call semi-structured data. And the example for semi-structured data is XML files. And coming to the examples of the unstructured data is one of the example log files. And the table data we call the structured data example. Right? All organizations have generating these three types of data. Now, before Hadoop, by using data warehouse tools, comes under like Oracle, SQL, DB2. So all these data warehouse tools, by using these data warehouse tools, we store the data and we process the data. But some drawbacks is there in our data warehouse tools. Those drawbacks we overcome by using our Hadoop. What is the drawbacks of the warehouse tools? Is by using warehouse tools, we store only structured data only. Right? It's not possible to store unstructured data. It's not possible to processing unstructured data. Only structured data only possible to store in our warehouse tools. This is one of the drawback. Second drawback is here volume of the data will be increased. Then our warehouse tools not possible to store those data. Okay, here we require more space and cost effective also. This is the second drawback. And third drawback is the process speed also it take more time when data is increased. For example, I have 5 terabyte data. This 5 terabyte data, I want to process it through warehouse. For example, take MySQL. Generally, 5 terabytes data, how much time taken to process through MySQL? Obviously, more time. It'll take 1 or 2 days also, right? But by using Hadoop, we can process within 3 to 5 hours time. Depends on the cluster. Okay, here point is basically some drawbacks is there in our warehouse tools. To overcome these drawbacks, Hadoop came to the picture. By using Hadoop, you can easily store any type of data, either structured data or semi-structured data or unstructured data. At the same time, we can store any volume of the data also. Any volume of the data. At the same time, you can easily process the data, more data in less time. This is the advantage is there. By that purpose, Hadoop came to the picture. Clear? Now we know that why Hadoop came to the picture. Now, what is big data? What is big data? We know very well in the starting days there is no concept of big data, there is no concept of small data. Only data is there. Any data has some features is there. Based upon those features, we say those data is a big data or small data. What is the features of the data? See, any data we measure based upon the 3 V's. Based upon the volume, velocity, and variety. Based upon these three reasons, these 3 features, we say those data is a big data. For example, volume means any data we measured based upon the volumes like GBs, terabytes, petabytes. Based upon this feature, we say those data is a big data. And the velocity means the frequency of the data, at which the particular time, how much data generating. Based upon this feature. And finally, variety means the data is structured data or unstructured or semi-structured. Based upon these 3 features, we say those data is a big data. Now, this big data is not possible to handle our warehouse tools. We require some new concept. That new concept is Hadoop. By using Hadoop, you can easily store it. At the same time, you can easily processing also. Okay, clear. Now, coming to the one more point here. We know very well like all 3 types of data. What is the source for structured data? Where it is generating? Yes, here banking transactions is the one of the best source to generating structured data. we transfer some amount of money from one account to another account. Every time some data is generating, those data we call it structured data. Fine. What is the source for unstructured data? Where it is generating unstructured data? The source for unstructured data is all social medias, one of the best source. Social media comes under Facebook, Twitter, LinkedIn. All these are unstructured data source. If you do any operations in the Facebook, every time some data generating, those data is unstructured data. Similarly, not only social medias, take the search engines. Search engines, for example, Google, Yahoo, Bing, these all are search engines. Huh? If you do any searching in the Google or Yahoo, every time some data generating, those data also we call unstructured data, searching data. Not only these two examples, we have number of examples is there. Take NASA, one of the best example. NASA keep on storing 24/7 weather data. Those weather data also like unstructured and semi-structured data. Okay, one of the biggest source. Not only these three examples, we have number of sources is there. All these sources are worldwide famous organizations, right? That's why some statistics also clearly mention every day 100% of data generating and 100% of data, only 20% of data is only structured. Remaining 80% of data is unstructured. Want to process this 20% of data? Our warehouse tools is fine, but we want to process 80% of unstructured data. We require some new concept, that is Hadoop. By using Hadoop, you can easily store this 80% of data, 20% of data also. At the same time, you can easily process 80% data and 20% data also. Okay, clear. Yes. One more point here I will tell you. What is the use cases here? We know very well number of use cases is there in our structured data. Similarly, what is the uses of the unstructured data? Why we are processing unstructured data? What is the reason? Here I will tell you some use cases. Take the Facebook. Everybody knows Facebook, right? In the Facebook, millions of users is there in the worldwide. Okay, each and every user, okay, every day do some operations in the data, operations in the Facebook, right? If you do any operations, if you like any advertisement, if you're posting any updated status, if you updated any status, every time data generating, those data is unstructured data. See, for example, in the left side of Facebook, in my cursor moving this time, some commercials will be coming. How it is coming, those commercials? There is no similarities between one Facebook wall to another Facebook wall. Different commercials will be coming to different walls. How to decide those commercials? Based upon our activities in the Facebook guys suggesting to this similar type of commercials. Okay. For example, we have the hobbies like online marketing. Then we like that commercial. Immediately, one log file is generating into the Facebook drive. Based upon that log file, Facebook guys suggesting to similar type of commercials into our wall. Now, immediately Facebook guys collecting all the log files and analyze it and find out how many are interested in particular product and approach into that particular advertisement organization, and simply they make a revenue, right? This is a Facebook business requirement. Similarly, take the Google. How to know Google, guys? This is the most famous person in the website. This is the most famous website. Okay, most of the people searching for this particular thing. How to know Google, guys? Because if you know any searching in the Google or Yahoo, anytime, every time some data generating. Based upon those searching data, Facebook guys analyze it. Okay, this is the most famous person in the website. Okay, here this analytics is possible through our Hadoop only, because by using Hadoop, you can easily store the data and we can easily process the data. Similarly, not only these two examples, we have a number of examples. Take the NASA guys. Here, NASA keep on storing weather data. No? How to know NASA guys? Like this is the right time to launch the missiles. NASA store the weather data different locations. Based upon those data, NASA analyze those data and find out, oh, after few days, weather may be cloudy or rainy, or this particular location, the weather situation like this. They can decide it based upon those past data. Right here, number of use cases is there in our unstructured data also. That's why by using Hadoop, you can easily store those data and you can easily process the data. Clear? Yes. And some history about the Hadoop. Yes. Here we have number of distributions is there in the Hadoop, namely Cloudera, Hortonworks, Apache Mapper, all are open source only. And the founder of the Hadoop is Dow Cutting. In the year of 2008, Hadoop is released by the Cloudera, and up to 2006 onwards, it's doing a research. Right? And one more important point here is, before Hadoop, how to handle unstructured data. Yes. Before Hadoop, we had different techniques is there, different storage systems is there. By using those storage systems, we store the data and we process the data. Right. Now everyone using the Google Hadoop. By using Hadoop, we store the data and we process the data. Small history. Now coming to the Hadoop architecture. Important one. Yes. What is the advantage of the Hadoop? We can easily store the data and we can easily process the data. These are the two main advantages. Right. Before discussing these 2 points, here first terminology. Yes. Entire architecture we call the cluster. Entire architecture we call the cluster. In the cluster, totally 5 daemons is there. 5 daemons, namely name node, secondary name node, HDFS client or job tracker, data node, and task tracker. These are the 5 daemons available in our Hadoop. I'm repeating these points: name node, secondary name node, job tracker, task tracker, and data node. These are the 5 daemons available in our Hadoop. These 5 daemons have different roles and responsibilities is there in cluster. Yes, what is the roles and responsibilities? Yes, before that one also, again some more basics. Entire architecture, only one name node, one secondary name node, one HFS client or job tracker only. But number of data nodes is there, equal number of data nodes, equal number of task trackers is there. Here in this architecture, only 5 data nodes is there. Some other architecture, 10 data nodes is there, 10 task trackers is there, and 100 data nodes, 100 task tracker. But only one name node, one secondary name node, one job tracker only. Yahoo have 2,500 data nodes, 2,500 data nodes, 2,500 task trackers, but only one name node, one secondary name node, one HFS client only. Okay, how to decide number of data nodes? How to decide number of data nodes? Here the number of data nodes will be increased or decreased depends on the input data. If the input data will be increased, the number of data nodes also increased. Okay, now coming to the storage. This is the terminology up to now. Now coming to the advantages of the Hadoop. We know very well the advantages of the Hadoop is storage and processing. We can easily store any volume of the data and we can easily process any volume of the data. Right. First we discussing like a storage. Once storage completed, then we will discussing processing. First storage. Data storing time. Name node and date node take the responsibility to store the data. Okay, important point, I'm repeating. Data storing time, name node and data nodes take the responsibility to store the data. Okay, why Hadoop have the capacity to store big data? Why not warehouse? For example, I have 5 terabyte data. 5 terabytes data I want to storing into warehouse. It's not possible. It's required more space. Okay, it's also cost effective. But in Hadoop, it's not required that much of cost. You can easily store it. What is the reason? We know very well the storage system in warehouse. See, we collect the data from multiple locations and place into one single space, single storage location. Right? This is completely like a warehouse storage system. Right? Based upon this architecture, it's not possible to store big data in Hadoop. Sorry, in warehouse. But why and how we can store our data into warehouse? Means, yes, how we can store those big data into Hadoop. Okay, what is the reason? Is Hadoop following one of the feature, that feature is distributing feature. Based upon the distributing feature only, Hadoop have the capacity to store big data. This feature is not available in our MySQL or Oracle. That's why our MySQL or Oracle are not possible to store those big data. But Hadoop have the capacity to store the big data means Hadoop following the storage system is distributing storage system. What do you mean by distribution? The term here distribution means simply divide it and spread it. Alright. I want to ask you one question guys here. For example, I want to build one wall or a house. Now one person try to build that wall, easily take 10 days time. Okay, same wall I want to build it 5 persons. Within 2 days we complete the work. Right? What we are doing? We are divide the work here. That's why we very much speed within the less time we complete the work. Okay, same feature applying here also. Here the 5 terabyte data we dividing into data nodes. Some data into one data node, some data into other data nodes. That's why Hadoop have the capacity handle big data. And all these data nodes are commodity hardwares, not required supercomputers, our general hardwares. Now in this data nodes, we store our data. Yes, for our convenient purpose, let's see small example. Just imagine guys, here 6 records is there. Just for our convenient purpose, just imagine 60 million records. Okay, 60 million records means something like big data. Now I want to store these 60 million records into my Hadoop. Obviously, it's not possible in our warehouse, but it's possible in our Hadoop. How? What is the responsibilities? Yes, we already knows the name node and that nodes take the responsibility to storage now. Now, first the requirement, the 60 million records requirement first come to name node. Here entire cluster only one node is there, that is name node. This name node take the requirement and analyze it. What is the input file size? Okay, 60 million records. Fine. After analyzing the input data, then name node analyze it. How many data nodes is there in the cluster? How many data nodes? Okay, 5 data nodes. And what is the size of each data node? And what is the free space of each data node? Name node analyze this. For example, there is no free space. This 5 data nodes, there is no free space. Now immediately name node requesting to administrator adding the extra data nodes. If the extra data node is added, then finally name node feels comfort. After that, name node give the permissions, store the data into on that extra data nodes. For example, 5 data nodes is there. In this 5 data nodes, free space is available. Each data node have 20 million records. Free space is available. Just imagine, here 5 data nodes is there. Almost 100 million records. Free space is available. Okay. Now name node first take the confirmation. Free space. After that, name node give the permissions, store the data in this data nodes. Here simply name node done the manage type of activities in the cluster. Before store the data, name node decided again here 5 data nodes, 100 million records. Free space is available. In this one, name node choose any of 3. After that, name node give the permissions. For example, name node choose data node 1, data node 2, and data node 3. Now, name node give the permissions, store our input 60 million records into first 3 data nodes only. Because this 3 data nodes more than enough to store input data. Once name node permissions will be completed, then our data will come and storing in these 3 data nodes only. As for order of the name node, the 20 million records will come and storing into data node 1, 20 million records data node 2, and 20 million records data node 3. I will show you one more diagram for better clarity. Observe this one. Here name node is there and 4 data nodes is there. Data node 1, data node 2, 3 and 4. Now name node permissions will be completed and name node says go and data stored into data node 1, data node 2 and data node 3. Okay. Again internally each data node number of blocks will be available. By default, each block size is 64 MB. Now based upon the data node size, the blocks will be depending. For example, data node 1 have 1 GB free space capacity. Now 16 blocks will be available in data node 1. Plus some small calculation is there. Based upon the calculation, okay, number of blocks will be dividing. For example, just imagine I have 2 data nodes is there. Here this is the data node 1 and this is data node 2. Yes, data node 1 and this is data node 2. And just imagine the size of the data node 1 is, for example, 1 GB. And size of the data node 2 is, for example, 4 GB. Okay. Now how many blocks will be available into data node 1? How many blocks are available data node 2? Small calculation is there here. The calculation is here 1 GB divided by 1 GB means 1024 MB, na? 1024 MB by the block size. Block size is 64 MB, right? 64 MB. Now, obviously, it's coming like almost 16 blocks. 16 blocks available in this data node 1. 16 blocks available. Right? Similarly, same calculation applicable here also. 4 into 16. But obviously 64 blocks will be available in data node 2. Okay. Now here, based upon the data node size, the number of blocks will be divided. Okay. Now in these blocks, our data is available. Okay. Now once name node permissions will be completed, now 20 million records will come and storing into data node 1, data node 2, data node 3. Now those data will come and storing into in this name node in this blocks only. Our actual data, our 60 billion, some part of data will be there in the data node 1, and the block addresses contains name node. Point is our actual data, our 60 million records, we storing into in this data nodes, and those data addresses, metadata contains in the name node. What is metadata? Generally, the term metadata is the data about the data. Generally, we call the metadata. No? Yes, same point applying here. Our actual data, 20 million records will be there data node 1. No? Those 20 million records addresses. The 20 million records, some records will be there block 1, some records will be there block 2, block 5, block 3, so on so on. Those blocks addresses contains name node. Actually, we don't know first 20 million records will be there in the data node 1 or last 20 million records will be there in the data node 1. But we know only 20 million records available. But name node knows this information. Name node knows everything. How many data nodes is there, and what is the size of each data node, and how many blocks available each data node, and what data is available each block. Everything is there in the name node. Okay, those data we call the metadata. Yeah, for your more clarity purpose, I will give one general example. Take one book. In the book, we know very well I want to enter in some 7th chapter. We check the index, entering into 7th chapter. Fine. There is no index, for example, just imagine I want to enter into 10th chapter. We check page by page and reach the 10th chapter. It takes some time. Right? See, to work on this time, we check the index. Same concept applying here also. Here in the index means our metadata is there in the name node, and our actual chapters, chapters means these Hadoop data nodes. Each data node some data. Those addresses contains name node. The block addresses, block size, everything will be there in the name node. Clear? And one more point. By default, the block size is 64 MB. We can increase this block size also. For example, I want to manipulate 64 to 128 MB block size. Then how many blocks will be coming? Obviously 1024 by 128 block size. Then obviously 8 blocks will be coming. 8 blocks only available. If I increase the block size, 8 blocks will be coming. Similarly, same calculation. Okay, based upon the block size, based upon the data node size, number of blocks will be divided depending. Now in these blocks we store our data, and the block addresses contains name node. Okay, and one more feature is there. That feature is replication feature. Replications feature. What do you mean by replication? You keep on maintaining the duplication, right? Same feature is applicable in Hadoop also. For example, just imagine guys, there is no replication feature. Okay, there is no replication feature. Now 20 million records available data node 1, 20 million records data node 2, and 20 million records data node 3. Okay, what is going on in the middle? Just imagine data node 1 is failed. Data node 1 is failed. We lost 20 million records. We have only 40 million records only now because we lost 20 million records. Now it's not possible to complete the job. It's not possible to fulfill our requirement. Right? To overcome this drawback, Hadoop following this feature, that is replications feature. Okay, here observed in the 4 data nodes is there. In the 4 data nodes, yes, for our convenient purpose, I will give some more clarity. Yes, 4 data nodes, data node 1, B1, B2, B5 blocks available. And data node 2 also 3 blocks is there, data node 3, 3, and data node 4 also 3 blocks available. Right? Again, observed here, B1 is repeating into again 2 data node 2 and data node 3. And B2 also replicating into data node 3. And B5 also replicating into data node 3 and data node 4. Point is, each block is repeating into multiple data nodes. Same in the B1 some data available, same B1 available in data node 2 and data node 3 also. Keep on maintaining the duplication. Why? Okay, what is unnecessarily waste of space, right? But why Hadoop following this feature? One of the biggest advantage is this one, replication feature only. Okay, reason is if any data node is failed, for example, my data node 1 is failed, and it's not required to stop all our jobs. Immediately name node analyzed, oh, my data node 1 is failed. Now what is the data available? Name node decided, check it based upon the metadata. Because in the name node metadata is available now, based upon the metadata, name node finds what data available data node 1. Now immediately name node take the backup. Here for example data node 1, 3 blocks is available, B1, B2, B5. Immediately name node find out the B1 available, okay, which data nodes the B1 available, data node 2 and data node 3. Fine. Name node again follow the some priority in these two data nodes, which data node is busy, which data node is working good condition. Name node from following some priority, based upon the priority, name node take the backup to of anyone. For example, data node 2 and data node 3, two data nodes B1 available. Now name node choose one data node, for example B1, and the name node take the backup to this B1 only. Okay, yes, based upon the overcome the failure, Hadoop following the feature is replication feature. For example, you know guys, Teradata, everybody knows Teradata, one of the distributing storage system. Teradata also same distributing concept only. But if any node is failing the Teradata, we stop the cluster and we take the backup. We stop all our jobs, then only it's possible to take the backup. But one of the advantage in Hadoop is it's not required to stop all our jobs. It's not required to shut down the cluster also. Work is going on, parallelly we take the backup, any node is failed. That's why Hadoop following this replication feature. I'm giving the overview. For storing time, this name node and date nodes take the responsibility to storage, and this name node is a master node. Only one name node is available. Now this name node take the requirement, analyze it, what is the input size, and analyze it, how many date nodes, each date node, what is the size, how many blocks is available. After that, simply name node give the permissions, store the data into so and so blocks. Once name node permissions will be completed, then our data will come and storing into, as for order of the name node, our data will come and storing into in these 3 data nodes. Okay, like this we completely store the data. Clear, storing is clear. Now processing. Why Hadoop have the capacity to process more data with less time? What is the reason? Yes, here processing time, this job tracker and task trackers take the responsibility to processing. Okay, for our convenient purpose, take the same data again. Here 6 records is there, just 60 million records. Now my requirement is how many are visiting my website, and what is the timestamp for each visitor, and what is the timestamp for each visitor. This is my requirements. How many are visiting and what is the timestamp for each visitor. This requirement first come to job tracker. Job tracker take that requirement and communicating to name node. What type of communication is going on in this HFS client and name node? Is this HFS client simply requesting to name node. Here I have some data, I have some requirement. Please give me the metadata information, that index information. I want to process the data. Job tracker requesting to name node, because name node only knows the information, that metadata information. For example, name node store the data in date node 1, date node 2 and date node 3. Those 3 date nodes so and so blocks. Those blocks information available name node. Once job tracker requesting, immediately name node respond and transfer the blocks, everything metadata to job tracker. Job tracker means our HFS client. Now HFS client knows client requirement, at the same time metadata also. Now simply job tracker forward the jobs. What are the jobs we writing now? We develop and forward those jobs to these 3 data nodes task tracker. Here the responsibilities of the job tracker is take the requirement from the client, after that communicating to job tracker, after communicating to name node and take the metadata, then forward those jobs to particular data node task trackers. Now this task tracker is subsystem to job tracker. What are the job tracker sending the jobs now? Those jobs simply this task tracker submitting into these data nodes. Then finally map reducing is started. Once map reducing completed, then finally you get the output. Okay, this is the number of visitors visiting your website. This is the average timestamp for each visitor. You can easily find out after completion of the map reducing feature. Okay, now I'm repeating. Here this job tracker and task tracker take the responsibility to processing, and this name node and date nodes take the responsibility to storing. Fine. What is secondary name node? Okay, what is the use of secondary name node? Before discussing secondary name node, I want to ask you one question. My det node is failed, for example. Then we take the backup to other det nodes based upon the replication feature, right? Similarly, my name node is failed. My name node is failed. How do I take the backup? If my name node is failed means we lost all the data. We want to shut down the cluster because if without metadata we can't do anything, right? In this situation, okay, it takes some time to resolve the name node failure. In this situation, secondary name node will be helpful. The secondary name node also similar like a name node only. What are the responsibility to handle the name node? Same responsibility to handle the secondary name node also. But some limitations is there. Some limitations is the secondary name node. Those limitations is, see, in our name node knows everything. Everything means what is the jobs running in the cluster present and what I'm already done in the cluster, previous jobs, and what I'm going to do it in future. Everything knows name node. But secondary name node knows only present running jobs information only. Secondary name node don't know what I'm already done in past and what I'm going to do in future. This information is not available secondary name node. Secondary name node only available present running jobs. For example, in the present 3 det nodes, some jobs is going on. Those information only available secondary name node. Because what is going on in the middle, my name node is failed. In this situation, secondary name node came into the picture and helps to job tracker and det nodes to complete the jobs. By that purpose only secondary name node is available. Clear? These are the 5 demands and these are the 5 responsibilities. These all are configurable only. Clear? And the last point is health monitoring of the cluster. Health monitoring of the cluster. What do you mean by health monitoring of the cluster? Yes. Before discussing this point, I want to ask you one more question. Just imagine, guys, we know very well, for example, our data is available 3 det nodes, det node 1, det node 2, and det node 3. Now, job tracker have the requirement to process the jobs. By that purpose, job tracker request to name node. Now, name node get the requirement from the request from the job tracker. Immediately, this name node transfer the metadata to job tracker. What metadata? Complete metadata. Now, in this metadata, for example, I want to apply the job into B1. Okay, job tracker try to apply job into B1, but B1 is available 3 locations. Det node 1 B1 is there, det node 2 B1 is there, det node 3 also B1 is there. In this situation, how to decide job tracker to submit the jobs into particular det node? We have only one B1 is more than enough, but here extra 2 is there. Now job tracker here following the some procedure, some process. Based on this process, job tracker decided to apply the jobs into particular det nodes. This process we call the health monitoring of the cluster. Health monitoring of the cluster. Okay, what is the process is? See, each and every det nodes you have equal number of task trackers is there, right? Equal number of det nodes, equal number of task trackers is there. In this architecture, 5 det nodes is there, 5 task trackers is there, right? Now, these 5 task trackers send in the signal to job tracker. The signal is data node signal. Data node signal. Every 10 seconds, task tracker send a signal to job tracker. Based upon the signals, job tracker decided after 10 minutes, by default time these are. After 10 minutes, job tracker decide, oh, based upon the signal strength, decide, oh, these data nodes are working and these data nodes are busy and this data node is failed. Job tracker decided. Similarly, for example, take human beings. Okay, human beings keep on 24/7, our heart is beating. Right, even when we are in the sleep, on that time also our heart is beating, right? Based upon our heart measurements, we decide, okay, the human being is healthy or unhealthy or alive or dead. We decide based upon our heartbeat, right? Same concept applying here also. Same example. Here task tracker sending every 10 seconds, task tracker sending signal to job tracker. The signal is data node signal. Based upon the signals, we decide those data nodes are working or not. For example, here 5 data nodes is there. The 5 data nodes, 2 task trackers is there. The 2 task trackers sending signal to job tracker properly. We configure 10 seconds, and the first 2 also sending signal properly 10 seconds only. After certain time, the job tracker decided these 2 data nodes are working good. The first 2 data nodes are working good because the 2 task trackers sending signal properly. And coming to det node 3 task tracker, det node 4 task tracker. These 3 task tracker and 4 task trackers sending signal to job tracker some delay time. We configure 10 seconds, but that node 3 task tracker sending signal 20 seconds. That node 4 task tracker sending signal some 30 seconds. After certain time, job tracker decide, oh, I received the signal from the date node 3 task tracker, date node 4 task tracker, some delay time. That means the date node 3 and date node 4 working busy, some other works. Okay. Now any new requirement on the time, job tracker decided choose date node 1 and date node 2 only, because these two are working good compared to 3 and 4. Okay. Now coming to the fifth one, the fifth date node task tracker is not sending any signal, even single signal also. First two date nodes sending the signal properly, and 3 and 4 some delay time, and fifth one is not sending any signal, even single signal also. It's completely stopped. Our heart also is not giving any beating, is not beaten. It stopped working. No? Simply we decide that man is died. Same applicable also, same concept here also. Here job tracker is checking after 10 minutes if any signal is there or not. If there is no signal, simply job tracker decide, oh, the date node 5 is failed, we want to take the backup. Like this, job tracker following this feature. Based upon this feature only, okay, job tracker decide to submit the jobs. Entire this process we called health monitoring of the cluster. And the signal, the task tracker sending the signals, those signals we called a heartbeat of the data node also. Heartbeat of the data node. Clear? And finally, Hadoop ecosystems. One of the beauty in Hadoop is ecosystems only. Here actually Hadoop is not a new thing. The combination of multiple technologies we call a Hadoop. Here in Hadoop, list of ecosystems is there, namely Hive, Pig, MapReducing, Mahout, Uzi, HBase, HDFS, Flume, Scoop. These are the ecosystems is available. Different ecosystems, different environment. Okay. Here we have the flexibility to the Java guys, at the same time warehouse guys also. For example, I'm good at in Java. Then I choose the MapReducing ecosystem. I can handle the project. It's not required to learn like SQL concepts, warehouse concepts. For example, I have the past experience in warehouse only. I came from warehouse background. Just imagine. In this situation, it's not required to learn Java because you can handle the project through Hive or Pig. Because this Hive and Pig similarity our SQL concepts only. By using these two ecosystems, I can handle the project. Similarly, some common ecosystems is there like a Flume, Scoop, Uzi. These are the common ecosystems. Okay, in our all projects. Based upon our experience, we choose the ecosystems and we handle the project. Now I'm giving the overview. Just today concept we will discussing like what is Hadoop, what is the reason Hadoop came to the picture, advantages of the Hadoop, and importance of unstructured data. Clear? Yes. Thanks for attending the class.